Good day, learners! Today, you will learn about Alright! So today, you will learn about inertia and mass relationship. So, come on! Let's explore and enjoy the world of science! Okay, before anything else, here are our objectives. Okay, first, let us define inertia. Second, let us relate inertia to mass. And third, let us investigate the law of inertia. Alright, learners, let us study about inertia and mass relationship. Okay, so before anything else, I want you to watch and observe this video clip. And later on, I will ask you a question regarding the video. Okay, let's play the video. Alright, so hello guys. So, I'm your teacher, Sir Rivera. So, ngayon, papakita ko sa inyo ngayon yung isa pang experiment na related sa topic natin about laws of motion. Okay? So, yung first law of motion ay yung laws of inertia. So, ano ba yung law of inertia? Okay, papakita ko sa inyo yung example ng laws of inertia sa experiment. Okay? So, ang kailangan natin is yan, baso, okay? Or any kinds of glass. Yan. Yan, basta baso. Next naman is cardboard. Yan. So, yan, cardboard natin. Next is 1 peso coin. So, yung 1 peso coin yun yung magiging subject natin or yung object natin. Okay? So, paano ba natin gagawin to? So, una, patong nyo lang yan dyan sa top ng ating glass. And then, itong piso na to, so, ayan, okay, ilalagay natin dito. Okay? So, tingnan nyo kung ano mangyayari. So, paano ba gagawin ko? So, ang gagawin ko, guys, is pipitikin ko tong, okay, itong cardboard. Wow! Then, obserbahan nyo, try to observe what will happen to the coin. Okay? So, ready na kayo? In 3, 2, 1. Wow! Okay. So, nakita nyo ba yon? So, mabilis, diba? Slow mo natin. Okay. So, ayun guys, 'di ba? Nakita niyo yung kung paano bumagsak yung piso dito sa baso natin. Okay, ayun yung piso. Ayan, oh. Ayan. So, bakit nga ba siya bumagsak? No? So, explain yan ng teacher nyo. Siyempre, ako pa din yung teacher nyo. Ayan. So, explain ko yan ngayon. Okay! Did you observe the video properly? Yes! Yes! I hope that all of you are keen observer. Alright! For my question, why do you think the coin did not fly out as I flicked the cardboard? Okay, so you think maybe it's because of magic? Or maybe you think it's natural effect of the coin? Okay, the answer for that is... It's all about inertia. Okay, are you familiar with the word inertia? Maybe you said, "Sir, it sounds familiar." Or maybe not. Okay, without any further ado, let us describe about inertia. Okay, inertia is the property of matter that let us an object stay at rest if it is at rest, or keeps it moving if it is moving. The word inertia comes from the Latin word iners, which means a tendency to do nothing or to remain unchanged, whether they are still or in motion. So meaning, the coin dropped at the glass bottle because the coin remained at rest. And at the same time, the coin did not absorb a greater amount of friction. Oops! You hear the word friction. Let us define friction. Friction is a kind of force that resists the movement of any moving object at the surface of any object. Okay? If the surface of the object is rough, it has a greater friction. If it is smooth, it has a less friction. So, in video that you watched a while ago, the friction of the cardboard is less because it has a smooth surface. So that's why the coin drop at the glass. It is because number 1, it remained at rest. Number 2, there are no other force holding the coin. There are no other force holding the coin at the top of the glass. And lastly, because of the pull of gravity, so that the coin dropped at the glass. Did you get that point?
Yes! Yes!
Well, very good. Alright, now every object has a mass. What do you think is the effect of mass to the inertia of an object? What do you think is the right answer? Okay, so before you answer that, let us first define what is mass. Okay, mass is the amount of substance in a given body material. It is measured in units called kilogram or a symbol of kg. The mass of an object affects the inertia of an object. But how? Before you answer that, I want you to watch this video again.
Uh-oh, I think we're gonna be late for dinner with our friends. I wish we had taken another cab instead. A newer, faster one.
Oh well, at least we had transport to get to the restaurant. It isn't too far away now.
Oh no, I think my cab has broken down. I'm so sorry, boys. I serviced it only a month back. I have no idea what's wrong with it.
Oh, it's okay. My friend and I will help you push your cab to the car workshop.
Looks like they're having a harder time than us. Poor guys.
Yeah, you're right, Alex. They're having a tough time pushing their van to safety. Do you know, though, why it's difficult for them?
Is it because the van is heavily loaded?
Exactly, and inertia plays a major part. Our cab has less inertia than the van over there due to its lower mass.
So, are you saying that greater mass leads to larger inertia? And it is the taxi's smaller inertia that's letting us push it to safety more easily?
Yes, and perhaps also because we're super strong. Let me tell you a bit more about inertia on our way to dinner.
Alright, learners! How the mass of an object affects its inertia? The mass of an object is directly proportional to inertia. Meaning, as the mass increases, okay, the inertia also increases. Try to look at this example. So which do you think has a greater inertia? It is the truck or the car? Okay, I sense your answer. Now, the answer is... Correct! The answer is the truck. Because the truck has a more mass than the car. Very good! Okay, let's have another example. This one and this one. So which do you think has a greater inertia? Okay, the greater inertia is the pushcart with a lot of item inside that pushcart. And the less inertia is the small number of item. Alright, learners, additional information is, did you know that the inertia is the first law of motion? Who proposed that law of motion? It is proposed by a famous physicist or scientist which named as Sir Isaac Newton. Are you familiar with this scientist or physicist? Oh, I know you are familiar with that. Okay, according to Sir Isaac Newton, the first law of motion is, it states that when an object stays at rest, it will stay at rest. Or when an object stays in motion, it will stay in motion. Unless there is or it is acted by an external force or unbalanced force. Did you get that? Okay, very good. An additional example for this is when you're inside a car and having a seat belt. So why we need to put a seat belt? Obviously, for safeness of the passenger once a car crashes. Did you know that aside from safeness of the passenger, there is a principle of law of inertia. Once a person did not put a seat belt and a car suddenly stop or crashes, the body of the person is continuously moving at same with the speed of the car. So that in that case, the body will bump to the car and will lead to death due to the impact of accident of the body of that person. So, if a person put a seat belt it prevents that person to move forward once it suddenly stops the car or crashes the car. Okay, did you get that point? Well, very good. Alright, moving on to our discussion. Now, learners, let's recall the lesson about inertia and mass relationship. Inertia is the property of matter that lets an object stay at rest if it is at rest or keeps it moving if it is moving. Okay, another. Mass affects the inertia of an object because as the mass increases, the inertia also increases. And lastly, inertia is the first law of motion by Sir Isaac Newton. Alright, learners, that's all for today's exploration. I hope that all of you learned in our discussion today. See you, learners, on the next exciting and much fun exploration about science. Don't forget to like, share, and subscribe to my YouTube channel, Survey TV, for you to be updated on my latest topic about science. Keep safe and stay blessed because I'm your teacher and you're the learners, and we explore the world of science.